The diagram shows a block of mass 8 kilograms being pulled up a rough slope inclined at 15 degrees to the horizontal by an inextensible rope with a force of 120 newtons. Given the frictional force is 90 newtons, find the value of the normal reaction of the slope on the block and the acceleration A. Now, before looking at this problem, let's look at this GeoGebra app, and the link to it I'll include in the notes of this video. So here we have a block being pulled up with a certain tension. So this is the normal reaction of the block to the slope, and this is the weight acting downwards, which is mg newtons. So whatever the mass is, it's going to be, in this case, it'll be 8g newtons. Now we have this angle here is 30, this is 30, then this angle here will also be 30. And if we click here, sorry, it's moving, so we have an acceleration of 8 meters per second. So the situation we've got is 15, so we'll just look at 15 to begin with, and we'll then move it. Okay, so that's 15. So if we click here, we will have the component of the weight acting down the slope, which will be mg sine theta, sine of the angle here, which is 15, which is the same as the angle here, and the one acting in perpendicular to the slope will be mg cos theta. You will notice that the length of this one will always be the same as the length of that one, from Newton's third rule. Doesn't matter what it is, you can see it getting smaller there. You can actually see that the normal reaction will always be the same length as mg cos theta from Newton's third law. Okay, so this video, and to resolve the forces, okay, so to resolve the forces along the slope, i.e. in the I direction, in this case it will be T minus this one. We're going to have a frictional force on this one, so we'll have one additional force down here as well, which we'll need to subtract. But we have, instead of being equal to 0, it will be ma using Newton's second law. And then if we're resolving the forces in the j direction, i.e. perpendicular to the slope, then it will be r minus mg cos theta, and this will be equal to 0 because the block is not moving in this direction. So in this direction, the resultant forces will be equal to 0, and that will allow us to find r and the acceleration, as we can see in this example. So step number 1 is to draw a good clear diagram of what you've got here. So putting in the weight here is 8g newtons. We've got a reactional force Rn, and we've got a frictional force acting in down the slope, because it's moving upwards. The frictional force will be acting down the slope of 90 newtons. So to find the reaction first, the normal reaction, so resolving perpendicular to the slope, that will be in the I direction on my GeoGebra app. So we've got R acting upwards, but acting downwards. If we draw in this line here, the dotted line, then this angle here will be 15 degrees. It will always be the same as what this angle is. Okay, and then this component here will be 8g cos 15. This component here will be 8g cos 15. So we need to take that from here and then put that equal to 0, and therefore r will be equal to 8g cos 15. We take g as 9.8 and work it out on a calculator. We're going to get 75.280 newtons, and normally give answers to 3 sigma figures, so that gives me 75.7 newtons. Okay, now resolving along the slope would help me find A using Newton's second law. We're going to have 120 minus the frictional force, which is 90. Now we have here the component of the weight, the component of 8g, will be acting in this direction. So if we draw that force in there, you can just about see it. That will be 8g sine 15. It's opposite the angle, so it's opposite the angle, so it will be sine. So we need to take that away as well, because that's acting that way. And now that will be equal to mass times acceleration. So the mass is 8 times the acceleration according to Newton's second law. So to rearrange that, we can get A by taking all of this. So 120 minus 90 is 30, minus 8g sine 15, and dividing by 8. So on my calculator, using my fraction button and g as 9.8, that gives me 1.213 meters per second squared, which gives me a final answer correct to 3 significant figures as 1.21 meters per second squared. Okay, and the GeoGebra applet that I used at the beginning of this video will be in the notes of the video for you to play with. I hope you've understood, and I thank you very much for watching.